Eller så. Hur många pratar svenska och hur många pratar engelska? Svenska.
Du kan ju inte ställa frågor på svenska.
Ja, precis.
Men hur många pratar engelska? Det kan ju inte fråga.
So we have, how many English speaking do you have? Like 1, 2? Plus the internet. Oh man. Okay, cool. So welcome. My name is Andreas, and I'm a technical tutor for kids, like at a local school here. And I'm gonna show you some basic projects that you can do easily to get started with 3D printing. And it's actually the first ones that I go through with the kids. And we started using Tinkercad because it's pretty straightforward to get started with. Och så kan vi ta det på svenska då. Eller ska jag ta... Följer alla på svenska med? Följer med? Det är gött. Yeah. So I was thinking of this as a workshop, so everyone should have a... But I'll make my own nameplate, or someone else's, and then we'll ask someone to print it. So whose name are we going to do a nameplate of? Anyone? Come on. Okay. What? Names? You won. Yeah. Okay, we have a name. And we don't have a mouse. Oh, it disconnected it. Amazing. Okay, let's do it with this. So you can do... we usually do it with this way. So, there we go. So, Tinkercad is really simple. The biggest problem we have is signing in into Tinkercad because it sometimes throws you out, sometimes it thinks that your Firefox or Chrome is too old. It varies, but after that it's a pretty straight thing. Are you familiar with Tinkercad? Have you used it? How many have used Tinkercad? 5. Good. What have you used it for?
That for me was quick edit to some design, split them or just try to clean them or do one little change at the time when I wasn't actually designing with CAD software. So
Okay.
it's easy to use it. And extreme tutorial.
Okay, yeah. It's a very crude tool. Yeah, it's but it's pretty fine to use for splitting things sometimes. It's actually so. Why doesn't the mouse work? I'll try this way. There we go. It's a table. So I'll show the nice features of the coolest feature of the software is how you split things. And boom, a lot of things. A ruler. Yeah, maybe I should move slowly. So were you here at the 3D studio thing? Or when Johan was talking, the other Johan? Well, he was saying that Booleans are bad in 3D Studio, and they are, but in this program is totally built around Booleans. A Boolean is when you take two objects and you put them next to each other, and then you make them either join, or destroy each other's, or interpolate, or all those things. So in this is called grouping. So we have these two groups, and you have two kind of colors or markers. So one is a whole, and then the other one is a solid, and you have two choices for the connect the shape that is selected. So you see the selection is the blue one, and then we have the red one that is a solid. We can click on it to make it a beautiful color. Boom. Blue. The color doesn't matter, it's solid or not. And when you group them, you do it up here. You have some options. Boom. And now that they're a group, the whole does its purpose. And if you want, you can actually go in afterwards and like, that wasn't completely straight with the other one. We can change that. Boom. And go out. There, we cut it. Sweet. So that's a nice feature. Cutting things. Okay. So now let's make the Johan sign. So delete everything. Nice. There we go. And so, well, we can either do it with text, but that's not so fun. So, in the right corner here, we have symbols. That's not it. Don't we have text? Oh yeah, we have text. These are fun. Like, then it's 12J, U. Do you have like an extra H or something? Like Johan?
Just an N right there.
Yeah. Sweet. And we're gonna like probably gonna 3D print it on. If we print it like this, it will be all loose. So we put it on a shape. So now we can go into like how to edit shapes. Like the box here, I'm thinking of it like to melt it down and put it like below U1, so that when you print it, you can have it as a name tag. Something like this. And then you have the name. You can have it as a whole or on top of it. You can decide that later. So this is where this ruler comes in to play in the right corner there. And then you can get all these mathy things, or not math, but you know. So you can put constraints. Like usually you want to, maybe when you're printing something simple like a name tag, you don't want it to be like super huge if you're gonna use it and bring it in your pocket. Maybe you want to have it to be like 7 centimeters or something. Oh yeah, the measurements here are in millimeters. You can see it down there. Awesome. And maybe not too thick. Let's see. So when you did the ruler, you got all these parameters, and you can write in how big you want it. So like maybe like 8. 8 is nice. And okay, and maybe 30. Okay, I want it to be that big. So I was thinking that the letters would make holes through it, so we'll make them into holes. Or should we vote? How many want the letters to be on top? 1. How many want the letters to be a hole through the object? 3. Okay. So it will be holes. Let's see. So I made it 8 millimeters high. So we need to make it at least there. And we have the height there, 4, 8. Boom. And let's see. Now we can we have these alignment tools, so we can smack them together, like, and have at least a straight line somewhere to start. And when pressing a line, you can press L, you get these dots. So this is aligned to the bottom, aligned to the center, and then the end. So the first one would join everything down there, the other one would put it in together, and the last one on the top. So I guess we would want to have them in the middle somewhere. I'll do that. So click on the center point, boom. And things are sticking out a bit. And we will move, what have I selected? Clicking onto things is a bit harder on a big screen. And you can use the keyboard easiestly, or you can type in the numbers. Just move that. Oh, that's not it. That's it. Okay, sweet. It's probably no. That's okay. So depending on the screen orientation of you, the keys change. There we go. And we don't want A. There we go. Nice. And to make the whole, we do it into a group, just like we cut the cube before. Ta-da! Now when we would print this, we would run into a problem. Like inside the O and the A, we have some loose parts. So there's different solutions for this. You could do connect them in some way, usually to, so like putting a small line wouldn't hurt too much. So let's see. For an O, maybe from the top down. For the A, maybe left to right. Let's do that. Another box. The box is great for this. And we don't want to make it too big, so maybe half the size of the other block. What?
Ego trip.
And let's see. That's awesome. Can't really see the. Sweet. I can move that into place. There we go. There we go. And then we can duplicate that. Boom. And that thing over here duplicates it, so you have an exact model on the same spot as the previous one. So when we're gonna do the connector for the A, we can just have the same size and then turn it. So turning things is a bit special. So you have these aligning things. When you do the turning, if you want to have it, you can do it 45 degrees snapping things. I think you have your mouse close to the object and then outer, a little bit out. I'll show. It will go in 1 degree steps. So here you have 45 degree steps, and then it's a bit weird. So if you have your mouse further away from the object, you can see I can move it into like small degrees. But if I have it close, it will snap to, not always. Okay, yeah, but we want 90 degrees. Boom. And we'll move it with the keyboard. So a bit down. And maybe it's a bit too big because it stretches into the H and N. So 10 maybe? 10 is too short. No, it's not. It's good. Awesome. And then, so now we got the name. So now we need to pimp this, right? To put stuff on top, there's, I mean, this work plane like works with that. So we can take another one on top of it, like a temporary work plane, so we can put things on top. So we drag this onto there, boom. And you can see that we now have the old blue one and a new yellow thing on top. So the yellow grid is, I stuck it on top of Johan there, on the brick, that surface. This could be used for sticking on other things, like if you're doing, like for the next side, if you want to work on that one, I have it completely stuck to that. You can put the work plane sideways. So, what do we want? Do we want hearts, stars, spikes? Any suggestions? Half squares?
Half Taurus.
Half Taurus.
There's a full Taurus. Just make the half Taurus.
Half Taurus. Oh, there's a Taurus.
Yeah, but half Taurus.
Yeah, we can just, you mean like rotating at 90 degrees into the thing?
I'll give you some creative freedom.
Yeah. We'll do that. We'll do 2 of them. Oops. Yeah. That's maybe enough. No, maybe 3. There you go. So as you saw now, they when I drag them in, they get stuck to the surface. The work plane that we dragged in just before. I could show you like putting it on the side there, and we could do there, and it would do the same on that instead. Maybe that's more clever. Yeah, let's do that.
Tires. Yeah. The tires that make the car.
Yeah, we'll make it a car. That's a great idea. So,
Transportation of the future.
yeah,
Sorry.
awesome.
Now it's gonna get really hard to print.
Yeah.
Yeah. Wow.
We should give it to one of the guys with the what you call printers. They seem pretty confident.
There we go. Awesome. And to kill the work plane, you should be able to just drag it in. This internet connection, or is it something else? There we go. Gone. Sweet. Well, I don't know. Maybe we can make it a little bit more. No, that's good. Done. Okay, beautiful. Applause now? No, maybe this was the first project. It was more. So let's. So after this, we can export it to printing it. We choose like STL or OBJ, whatever your printer software likes. Probably STL. And yeah, we're done. Okay, let's make a new one. Yeah. Do 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 do. Do you have any things that you learn now? The people that, yeah.
You learn the workplane tools from YouTube?
The workplane tools? Do you want to see something more? Like it's a simple project. We could do something. Do you have any ideas of like what you want to like do? Otherwise, we will make an animal like with 4 legs. Yeah, we'll do the pet. So the next thing we usually do is like make people do something with 4 legs, a pet or something, because then you can show how to do like balancing the legs and height of stuff. Yeah, well, let's make yeah, something like this. Maybe wormy stuff. That. We can make so. And what legs are we gonna have? Cones? What?
The one with
The polygon ones.
No, the paraboloid ones.
Parable.
right.
That one. Yeah, yeah, that's it. Definitely. This one is a bit big. Let's make it smaller. We can use, oh yeah, the handlebars. If you can, these handlebars do different things, like the edges with the whites. When you drag them, you deform it in 2 axes at the same time. You can use the keyboard holding in Shift, yeah, to do it all axis. And it will scale evenly. There we go. Yeah. Oh, I won't be able to see that there. Oh. And then just copy a couple of them. I didn't duplicate that. Duplicate. Duplicate. There we go. So it has 4 legs. Kind of. I'm thinking this as the face. We'll put some eyes to it. Maybe green eyes are good. That's, there we go. Ba-ba-da. Shoot. Yeah. And we can also pull things with these arrows. See that one that turned red? Off. Far out, so we can do the. There we go. Sweet. Now we have a small animal. It's beautiful. We can print it and then we can pet it all day long. It's awesome. What?
If you want to raise the body above the feet, you need a different plane for
if you want to raise the body, like you may like move these one up. No, you can use the same. I'll just group them first so that they move the same time. First, let's see, like that. Yeah, I got these two. Oh, it's also yeah, you can shift select stuff and make group. And sometimes, if you want to keep now that we group, the eyes will change to the same color, but we can choose this fancy function of the multicolor to keep it. It isn't changing. Interesting. You can see the height here from the ground. So you can just type in there, or you can drag this. I can show you both. So, like this. Or you could, down here, like if you wanted to have it, I don't know, like the legs were 8. You can just make them, or maybe let's make it a little bit lower, like 6.
Print something like this that is not connected together.
What?
It would be interesting to print something that is not really connected together.
Yeah, what it will do is to, like, the slicer would add support material to print it when it's not connected to the ground.
Now we have, in some places, I think, an air gap between the body and the legs.
Yeah. Yeah.
I think the legs needs to be taller.
Yeah, I think the legs should be taller. Let's see, maybe... How tall? Like 15? Yeah. It works. Let's see, and we can just drag them in a little bit. There we go. Those are connected, definitely. Sweet. Yeah. Maybe we want the head to be a little bit more proud. Let's see. A little bit higher. Do we get the... There we go. Sweet. Yeah, that's mostly what you do. Let's see if we can show. Okay, so extras, share. Oh, I love these names. They're like already like Bumble. This is a Bumble, and it's also neat. Oh yeah. There are some Foxlayer. Does this put it in a Minecraft thing?
Yeah,
Yeah. This is awesome. So this is how it would look in Minecraft. Totally. You can see it's more
This is what blocks to use.
yeah. So it's more rumble in this. And oh, they moved the shape generator here. Let's see. Yeah. Last week they removed this. It's back.
This is JavaScript.
But this is JavaScript.
You were talking about
Yeah. It was SCAD. Okay. So they removed SCAD to make JavaScript. Sweet, okay. Yeah, I haven't practiced that, but there's probably good guides of doing, let's try something. What can I do? Like, what does it say? Mesh? Are there like any, can you just do like this? Like, 10. Yeah. Where do we see any errors? Oh, it says ID range display now.
Underlined in red, but now not. Compiling, so.
Too bad. Maybe next time. That what I tried to write was something that works in SCAD, but does not here. I'll get that. So, I guess this is like Tinkercad is like really simple. This is mainly the things you can do with it, and from here, it's pretty much a tool to get started with things, getting ideas quickly, and also it's very shareable, and also it's solid, so you can print them. It's a really good tool to get started to work with, but in the long run, it's limited. But it's really to get the sense of 3D environments, cutting things, putting things together. It's good.
Any specific tips on making things 3D printable, on designing things specifically for 3D printing?
When you design things for 3D printing, well, like make sure that things are connected. I don't know. Are there any ideas?
Any tips like, you're saying make sure things are connected, do you need to merge the shells manually, or are there especially exports?
This software is so nice that it does it for you. So if I would export this, it does everything for you. So it joins it to one STL file. I think it's in ASCII format, so it's convertible to other things. So if I would want to download this, and then I could do like Blender or something. Oh, I haven't installed Blender? Oh shit. This is awesome. How big is Blender? 80 meg. That's not too. Can do what? I thought I had that. Anyway, let's figure out where this got downloaded to. It went to. Jesus, what have I done? Yeah, so it's a reliable thing. It does lots of things for you. So even though like I didn't group those things, right? I grouped the body and the head because the head was a separate part, and you can see like it's been there's a. Can you see this? That there's a hole here. Yeah, it's connected. You don't see two meshes going into each other, and the eyes don't have the complete circle either. So yeah, the Tinkercad does all the Boolean operations in a good fashion. It's good for that. Yeah. So if you're new to 3D printing, this is or like 3D. This is a really good place to start. I think that's any questions or ideas? Yeah.
What is the most common problems for the kids? What is the hardest for them to learn?
The hardest for them to learn? In Tinkercad, nothing. I think it's when the hardest things are when working with usually when working with something that like using mostly happens in SketchUp or is that some things are disconnected, so there are holes in them, and then repairing them, and we like SketchUp is not a good program, so we usually teach them a lot more Blender, because then they get used to like repairing stuff and connecting the dots. But usually Blender is a too big step in the beginning, just seeing dots. So this is a good start, and then so there's like a missing link somewhere between Tinkercad and Blender that we really haven't found. It should be SketchUp, but it's not. Because SketchUp also does a lot of things with normals. It corrupts the way that things are facing. So, for instance, if I would move this, or I would expand something, there's a if you drag it out once and then do it again, there's a 50% chance that SketchUp will do it with the normals inverted. So you're actually dragging out thin air, but it looks like something. You will see it in the 3D software, but it's hard to see if it's shadows or something else, if you're new to it. So yeah. So that's the hardest part, normals and holes. But it's often mostly caused in SketchUp. So don't do SketchUp. We should do something else in SketchUp. Yeah. Yeah, I'm done. Thank you. Sweet.